Hello. It's good morning to me. I guess uh, well, is it still morning over there? Sorry, I'm a little time zone confused here.
Afternoon.
uh, Afternoon. So good afternoon. I'm Scott Ananian. My teammate Subbu is here virtually as well. He and I work on the content transfer team at the Wikimedia Foundation. We're broadly responsible for taking Wikitext on a page and turning it into HTML, a few other things besides, but that's what we're going to talk about today. So Parsoid is the next generation Wikitext processor, the piece that turns Wikitext into HTML. It was started in 2011, and we've been maintaining it in parallel with the legacy Wikitext parser for 10 years now, more than 10 years now. And it's time to retire that old code and move to the newer Parsoid code base. But of course, part of the motivation is to enable more innovation in Wikitext itself, both in the semantics it embodies, as well as we think about the way we think about an article in terms of the composition of meaningful and typed fragments. So we're going to focus a bit more on this aspect today. What is the thing that we're trying to use Wikitext to express? What is the computation or analysis we'd like to present on this page? And what does that look like for an author or editor of Wikitext? Backing up for a moment, just for review, why did we replace the legacy parser with Parsoid in the first place? What is Parsoid doing that the legacy parser isn't? Well, the original motivation for the change is that Parsoid generates better, more semantic HTML with the additional information that's needed to support the user-facing features that Parsoid was designed for. So visual editor, content translation, and then discussion, first talk page support, first flow, and now discussion tools. Providing that semantic information about the content of the page allows better editing tools, better bots, better gadgets, and better search. But also maintaining two parsers in parallel is just not feasible long-term. The legacy parser was not built in a way that allows us to implement the features we've got planned. The long-term switch, the trend here is away from manipulating raw strings of HTML to manipulating structured DOM trees and giving a more principled semantics for the composition of a page from typed fragments. There's still a sizable transition window ahead of us. Our initial focus will be on transitioning the Wikimedia cluster and supporting all the uses that WMF already has in production. And then even after we've turned off the last remaining user of the legacy parser in WMF production, Foundation production, the intent is still to maintain the legacy parser as a community-supported add-on, either as a library or an extension that you can optionally install. But at some point, already new feature development is occurring on Parsoid. And where are we in this transition? I'm not going to belabor this. We presented more of the roadmap in our talk a year ago. But Parsoid has been used for editing Wikitext, first from Visual Editor, and then in the new Wikitext editor, content translation tools and whatnot from the start. The main focus of our work right now is transitioning readers to Parsoid, using Parsoid generate HTML for the article pages that readers see, starting with talk pages where users has opted into discussion tools. There are also some semantic changes to how things like images actually appear in the HTML, and that work is ongoing right now. We've transitioned the first few wikis. We're about to start the work to turn on Parsoid for read views and discussion tools. We've developed equivalent backend support in terms of parser output and parser options, and we've have an initial extension API. There are some improvements that we'd like to make to it, which we'll talk about a little later. So again, why are we doing this? So once we've got unified Wikitext parsing in one code base, we'll be unblocked on a number of improvements we'd like to make to template, syntax, and structure. I'll generally use transclusion rather than template in this talk. Transclusion includes parser functions, magic words, extension syntax. Under the hood, I'd like to think that they're all more or less the same thing, just slightly different syntaxes for it. Other improvements include here.doc syntax for arguments. The way that caching is done in the infrastructure is also being restructured with a transition to more post-processing. So Parsoid, unlike the legacy parser, tries very hard not to include any user-specific rendering. So its output is independent of user preferences. It's more or less a canonical form that can be cached more robustly. All the user preference stuff and potentially other frequently varying bits of the page, like red links or even media sizes, are intended to be performed as quick post-processing steps. So In general, we seem to be moving to an architecture with separate parse steps, including independent parses of separate sections of the page, and a final compose step or pre-processing step, post-processing step to stick the incremental and partial parses together. In the context of abstract Wikipedia, it's even proposed that we might do multiple separate compose steps for the page as different bits of the content become available asynchronously and are rendered. So that's mostly what we're going to talk about today, this sort of high-level overview of how the page is constructed, because it might affect Semantic MediaWiki and how we think about caching and expensive queries or computation on a page. So the big picture, the direction we'd like to move in terms of putting an article page together. This is mostly platform work, not Semantic MediaWiki, but it can be helpful to get us aligned in the same direction. The big idea is to think of the page as being composed of multiple independent fragments that are plugged together in a separate compose step. So each fragment needs to have an appropriate shape. So a string containing a fragment of Wikitext text is a quite difficult thing to compose. That's sort of what we're working with now. It could have, unpaired brackets and whatnot. But something like an HTML DOM tree or a forest is a shape that holds its, is a thing that holds its shape well in a variety of contexts. You can plug it in without changing the context very much. These are the two types currently present in MediaWiki, fragment of Wikitext and a DOM tree to some degree. But we'd like to also consider other fragment types. And the reason is that those fragments frequently show up as arguments to other transclusions. And we know we have a rather rich informal type system already for those, which we express through the template data extension. Rich types for fragment parameters also provide for good editor support. We can provide the appropriate input widget for the type of the argument, and basically provide appropriate fragment editors for those pieces. As a performance matter, these fragments can be independently cached, so that if a page is edited, we can recompose it with the fragments that we used earlier. And similarly, if a fragment is edited, it can be recomposed without reparsing the entire page. And this is an important step towards allowing slightly more computation to go into a page, because we're not redoing that computation every time you edit either the page or any of the fragments that go into the page. So we have a document with holes in it, and we have fragments to plug into those holes. Some of those fragments have holes and fragments of their own, of course, but that's not quite enough. Many existing features in MediaWiki require a global reconciliation path. A simple example is citations, which are sequentially numbered throughout the document. So if fragment A precedes fragment B, and fragment A is edited to contain more or less citations, include in this architecture a final post-composition step where we can do these sorts of global passes. We try to avoid this if necessary. For example, often we can do the numbering in CSS, and then we don't need the numbers to be explicitly present in the HTML. That's a little more friendly for editors, because that means if Visual Editor inserts a new citation, all the new citation numbers get done by CSS, and the editor itself doesn't have to maintain this global consistency. But when we do have a post-composition step, we like to keep them as short and quick as possible. You can use this to emulate a lot of apparently sequential behavior in this final pass, but the code to do so usually looks very different. Instead of doing computation incrementally immediately when a fragment is rendered top to bottom, you need to keep all the information about the computation around in the fragment's metadata. Typically, the set extension data method of parser output is used, so that the actual computation can be done later in the post-processing path. Now, we will most likely implement legacy compatibility modes where we either use the legacy parser directly or turn off fragment caching and other optimizations. So you don't have to worry that your code is going to break overnight if it doesn't fit this structure, but this is the general direction for future platform work. So let's talk more specifically about concrete impacts to Semantic MediaWiki code. These are the ones that we know of. Part of the goal of this talk is to solicit from you all other implications, other interactions that we might not be aware of. So there are three main impacts, and we'll discuss these in a little more detail in the next few slides. First, as we just discussed, features which depend on a linear parse order will be increasingly discouraged, although there will be workarounds and compatibility modes for quite some time. A part of this is the way that metadata is represented in parser output has already shifted in MediaWiki 139 a bit to allow it to be composed in an ordering independent way. Second, in terms of syntax, we're trying to standardize on the brace hash parser function syntax. The old square brace extensible link syntax will be sort of reserved for actual links. So all new template features such as here.doc arguments are expected to be supported in the brace hash syntax. And we'd like to ensure that any other syntax forms that are present, like the extension tag and magic variables, can be expressed as equivalent parser functions as well. That's fab test 204-370 mentioned there. The extension tag syntax is often the cleanest way to embed non-Wikitext data in a page, since it has very straightforward escaping rules. And so it will be preferred if you want a stable API above all, and that's because, so the third point there, we're likely to be extending the parser function API in the near future. So we'll talk about that a bit later. And these are the three areas that we expect to most impact Semantic MediaWiki. So let's briefly revisit the issue of link syntax, the double square bracket syntax. We discussed this in more detail at the last SMWCon last year, so you can go back and review that recording for more detail. Without going too far into the weeds, I believe the community consensus right now is to migrate to the alternative parser function syntax for embedding semantic data in a page. I'd certainly like to hear from folks whether they feel like they need more migration or linter support for that change. Last time we also discussed the variables extension. It uses hooks which aren't present in Parsoid and contains a read, modify, write model, which is not particularly consistent with the fragment composition model that we described earlier in this talk. It's not alone in that, by the way. There are a number of core MediaWiki features which all have similar effects on all following wiki text. Citation numbering I mentioned. Language converter rules can also have effects after site of use, although the way that they're used in practice tend to be grouped at the top of the page. We're gradually trying to address all of these, but we'll have backward compatibility mechanisms in place, which will most likely work for variables as well, at least for some time. But again, we're sort of pointing the direction towards trying to keep the fragments independent. The variables extension also has a construct called var final, which operates only at the very end of the parse after all the variable assignments have been done. Although awkward, this is incompatible with the composition post-processing phase we discussed. We could also include an explicit linear parsing compatibility mode for this and other extensions with this sort of behavior. But thinking broadly, if you are using the variables extension to, for example, keep a running total as you process every row of a table, generating the rows from the semantic data in your wiki, so that you could display a grand total in a row at the bottom, there are other ways of structuring that task. And Marijn at Wikibase Solutions has a very interesting approach, which he demoed for us a week ago now, and I hope he'll be able to demonstrate for you all if we've got time at the end of the session or between sessions. We'll take a look at that here, and forgive me for getting some of the details wrong. I think his work is really interesting. It's very much, as I understand it, in a beta phase, so everything can change. But the key idea is the separation of presentation and data. So rather than interleaving the computation of each row with the wiki text and formatting of that row, which has these implications for linear parsing order, seems to require it, at least conceptually. The goal is to achieve a clean split and keep all the computation in a separate place than all the presentation layer aspects. So to be clear, this particular architectural direction for page composition is something I am very passionate about. I do think it's got a lot of benefits, and we should be pursuing it. Indeed, I've made several proposals around this area for example, in previous Wikimanias, but I don't expect the foundation to do anything significant here anytime soon. But it does look that Marijn and Wikibase Solutions is exploring something which I think is very interesting in the space. So let's see how what they're doing ties into these broader parsing directions. And forgive me, I've probably gotten many details of the syntax not quite right, but the basic idea is that every readable page actually lives in three separate parts. The actual main page that's being rendered is a single line of wiki text, which invokes a template containing the presentation layer with a single argument, which is an invocation which computes the data. In the context of the presentation layer, there are a number of functions which work on the data, which is provided as argument one, triple brace one. These contain the functions you'd expect to interrogate a structured data object, like fetching specific fields or iterating over arrays or keys and values, or just printing the whole thing for debugging. Here I've done a very simple for each function to generate a table. And that's in the bottom left there. In the bottom right is the Ubuntu module, which does the data computation. So the idea is it does whatever complicated calculations and queries it needs to, again, referring to the semantic data stored in the wiki or even calling out, then calls a special export function at the end to pass this structured data, a chunk containing all the data for this page. Here we're just using a simple array to the presentation layer. So there's three things to note here. First, I've used the explicit HTML syntax for tables because the native Wikitext syntax for tables uses vertical bars. Vertical bars play very poorly with arguments and transclusion syntax, which are generally separated with vertical bars. So we have a proposal for HereDoc syntax, which should help a lot in constructions like this. Look forward to that. Second, the reason that main article is a single line is that Marijn is using a very clever hack here to ensure that the data is only computed once. So by structuring the top level invocation in this way, passing it as a template argument, we compute the data exactly once and then reuse that expensive value multiple times in the body of the presentation layer, referring it to as triple brace 1 each time. So that's a very clever way to avoid recomputing the data multiple times. Third, I haven't told you the exact format that structured data is in when it's passed from Ubuntu through Wikitext into that AF for each function. And you don't need to know. In actual practice, it's nominally JSON, but it is being passed through Wikitext, which doesn't natively have a binary or raw type. So there are various corner cases where particular JSON values would get mangled by the parsing layer. So Marijn is actually base 64 encoding the JSON value to protect it from the parser, but that's just an implementation detail. More or less, it's invisible to the author or editor, and it could be changed from one release to the next without affecting the code that the author or editor wrote. So this is a very interesting architecture which separates presentation and data, and it's exposed three issues which are very interesting to us in the parsing world. First, embedding certain Wikitext constructs in transclusion arguments can be tricky. So if you're using parser functions as your as a way to tie your presentation layer together with data, there are some things which are hard to write. HereDoc arguments should help. We're in general very interested in sort of syntax hacks and regularizing the escape syntax in Wikitext to make this more straightforward. Second, we needed to memoize that computed data, and I've mentioned this fragment composition framework. This is the sort of larger frame of the work. We'd like to generalize those mechanisms to allow broader memoization and reuse of other types of fragments. But the particular way that Marijn is doing it seems to work very well, at least for the short term. And then we're passing structured data between transclusions. It's both, as the output of one transclusion of parser function as the input to another, a standard Wikitext template. So we think that richer types for parameters and results would help here. We should really need to do this crazy base 64 encoding of a JSON blob. And so this last issue brings up the last item that I wanted to bring to your attention. The parser function API is currently an area of active work on our team. So the existing API for parser functions is quite primitive. It doesn't even support. And when these are manually implemented extension authors, the results tend to be subtly incompatible with other types of transclusions. So we're hoping to introduce a better declarative API for registering parser functions that will also allow somewhat richer input and output types and be compatible with the use of template data for describing the arguments to these parser functions. So that's all I've got. I hope we have some time left to discuss all of this because what I really want to do is hear from you all. And like I said, Marijn has a really interesting demo. If we've got time or between sessions, that would be interesting to show as well.
Yeah, we don't have time right now, Scott, because we have a tight schedule. But we have a few minutes for discussion. Does anyone have questions or things to add? Simon, can you come? Yeah, please.
Yeah, thanks for the insight. So just two short questions. So there was a JavaScript implementation of parser, but that's deprecated, isn't it?
Yes. So yeah, we ported Parsoid from JavaScript to PHP. Subbu, help me out. 2 years ago, something like that. Now.
Yeah. Okay. And is there any plans to also have a JSON representation of a wiki text, or is it just about have the wiki text or the HTML or the enriched HTML representation?
Yeah, we've our HTML DOM is the sort of canonical representation of the wiki text, and you can map each individual subtree of that DOM back to a particular wiki text string. There are a number of tools that help working with that DOM. The famous one is MediaWiki Parser from Hell, which was written in Python, which gives you friendly ways to sort of skip through parts of the wiki text. There are versions of that built on Parsoid HTML as well. So if you want to do sort of interrogation of the structure of a document, the intent is to do that on top of the HTML DOM and use that as the data layer. I mean, you could of course use different syntax for that, but the syntax we're using is HTML.
Okay, yeah. Thanks.
So Scott, thank you for the attention for Marine's work, and we'll have to find a hole to squeeze that in, but I don't think that's going to be today. And Friday you have to learn for your exam, and tomorrow as well. So I think we have to think of a different way to approach this.
We say, hopefully I've whetted everyone's appetite for that whenever it happens.
Okay. Hey, thank you very much. And I think we are going to move to bye. Can you I think Scott wants to see us all wave.